Right. So delegate is something that we started in our last session. And as I said, I'll just repeat for everyone who have just joined us. From next week, starting next week, we'll start talking about our final project, the project of the course. And what I would be expecting from all of you is that I would be just expecting to just try to start thinking about your groups and everything, and then we will be just looking into that matter so later on. So today, as I said, that I will be just starting giving a quick review of delegates along with some of the interesting concepts that we want to discuss. And as I said, there was a question from someone, and I'll just try to reply that question also as well today. So we talked about delegates, and it's more like the function pointers, you can call them. And we said that they'll be playing very important role in when we'll just start talking about the Windows, ASP.NET, Microsoft GUI. When we, as I said, from the next week we'll start talking about the GUI, graphical user interface, how to create those interesting graphical interfaces. We'll just start talking about that one. So there it will help us a lot more in our delegates. All right. So now if you see that, if you remember that we have talked about that we can declare a delegate. So there are multiple ways of declaring a delegate. So today I just wanted to start with, let's just start a project today. That will be the code that we'll share. And I will be just sharing this code with you people. So that's why I'm just, okay. Okay. All right. So let me just. Yeah. So as you remember, we have talked about that you can just define your delegates in multiple ways. There are multiple ways of defining them. So I'm just giving a quick review for that one, because I want to work on our today's today's example, and we'll build up on that. So you remember that if you want to define a delegate, we have to use this word delegate. And as I said, unless we start talking about the, as I said, the good, the GUI programming and all those things, we will not able to appreciate that much the delegates. But anyhow, we need to know the concept of delegates, which is basically important. So I am defining a delegate that has, for example, my delegate, I'm calling it, and I'm saying that it is accepting one integer. Now, a very important aspect, just for the review purpose as well, we have already talked about it, but again, I'll just say. So I've tried to define a delegate. Now this delegate might point to a function that should have the same signature, so to speak. For example, a delegate will be pointing to a function we know, and we say that this delegate should be pointing to a function which has exactly the same syntax, not syntax, the same signature. I hope you remember about the signature, and we specifically say that signature, if you remember, signature is what? The name of the function with parameter list. You remember? But here what we are saying, that there is one more consideration when you talk about the delegate. Here the return type will also count in this, will be also counted. So first of all, this delegate can point to a function which necessarily should have this signature, not returning anything, the void, and accepting one integer value. So if I have a function of this nature, right, this delegate can point to that function. I hope that makes sense to everyone. Now let's talk about it, and let's create a function. For example, public static void my method one. I'm just calling it my method one because I will be just building upon that. So I'm defining a function over here, my method one, and you know why I'm defining it static. Of course, you know that I don't want to create the object of this program class to use that one anyhow. So now what I see, that this is a method. That method has basically nothing special. It just does what? It just returns or prints out what it accepts, right? So again, making life easy. So now the important thing to notice here, this delegate, whose name is my delegate, it can point to a function that has exactly this, this signature, right? Now I am defining a function that I want this delegate to point to. So I've defined a function, public static void my method. So you see, do you see the resembling of those two functions? Why? Because this function has to be, because I want this function to be called by the delegate and all those things, right? So we can have this one of the things. So now the two methods that I was talking about, there are two methods of using this delegate or pointing this delegate, and we have used one of them. So if I say my delegate, right, and I say del, right, I'm just naming it del, and there is one method is, if you remember, I don't know which one we used last time, or maybe you can just correct them. So we can just do my delegate, and here we can just pass that function name. So you remember, we can just pass that function name. And what is that function that I want to pass over here? My method one. Now this is one method of defining a delegate. Can anyone just please confirm, did we use this method of defining the delegate, or we use the other method that I'm about to tell? There is another method of defining the delegate function, is that I can use this my delegate del, for the timing I'll call it del1, for example. Why? Because that will be the other method, is that directly you just define or you give your method name over here. Both of these represent the method of defining a delegate and pointing to a function. So which one did we use, the line number 10 or line number 12? Can anyone just confirm me? Yeah, so we use the first one, right? So Monarch says that we use the first one, right? But this is another method where what I'm doing, I'm just defining a delegate, right, and allocating it a function name. So it means right now delegate one, del1, del or dl1, both of them are pointing to the same function. And what is that function? This my method function. Is that right? So now if I do something like that, so again, whatever method you want, you can use that. So since I used that before, so what I'm doing, I'm not using this one right now. I'll make it comment for the time being. I'm just using this one and just calling it del, right? No issues, you can call it anything, but of course the same name cannot be repeated. So I am just now using this method. My delegate del is equal to my method. This is another method of defining a delegate. And now what we can do is that if I say del, and if I pass any value 10 or whatever, and if I just run this program, what I'll see is, of course, there is nothing like no rocket science. What will happen? This del will call my function, and that function will be passing that 10 value, and that 10 value would be printed out on our output. That's not a rocket science. Now this is I've just discussed that to give you a quick review of that one. So again, some of you might come up and say that why bother doing all these things? Wasn't that like that as well if I do my method one, and as I said, and pass a 10 over here? So why we are bothered doing all those things? So as I said, we might do not realize, we might do not appreciate the power of delegates unless we reach to a point where we start using these delegates. So yes, you are right that this is also an easy way. But now what we are doing is that now we have got the reference of this function in a delegate, And now we can do a lots of things with by using this delegate. So if I just, you remember we have talked about this to define delegate. We can just define my delegate, and we can just call that one, and we have just. So this is something that I want to discuss today, which we have not discussed, and this plus equal to, and I'll just talk about that shortly. Now, so example, and you remember we did this example also with and without delegates. If you remember that this is a class employee, that we say that it has integer ID and string and salary and experience, like all of these are the properties that we have set up with the get set and everything. And then we define a function, and we define that we are just adding the employee list, and after just checking which one will be given promotion. And you remember that we talked about that promotion will be done on the basis of this logic that you have set up. And again, then we said that if we want to make this program as general as possible, we want to just make it generalized. What we do is that we just try to do something like that we define a function. Function will be defined by everyone else, like that function can have any logic in it. And we had used this delegate that was just taking care of all those things. So if you remember, this delegate is taking care of what? That this function, this will be a generalized template. This will become a template, and now you can just pass your function of promote, whatever promote function that you create, it will be just passed over here, and this logic will be running over here. And we have just talked about that. So I just what I want to talk about is multicast delegates. And as I said, this was a question asked by a student. So a multicast delegate is a delegate that has reference to more than one function. So we can have a reference to more than one function of a delegate. A delegate can point to more than one function. We can use either plus or plus equal to register an additional method to delegate, and minus or minus equal to register unregister a method from the delegate. So we basically do what? We can use this plus equal to or minus equal to refer to more than one delegates that we might have. So multicast delegate is basically something where there are multiple methods, and you want to use the same delegate to point to the multiple methods, and you want to just represent the multiple methods. So let's come back here and let's try to do something interesting. I'm just deleting this one. I'm just having right. So now let's talk about, I have another method, and let's create my method 2. So I'm just creating my method 2 over here. And again, this method is also doing nothing but just accepting a value and printing that out. And now here I want to do something. My delegate del1 equal to my method 2, right? So I've created 2 delegates. Now not calling this del, rather I'll just, or maybe just let's call them 1 and 2. 1 and this one is 2. So we have created 2 delegates. Now what I can do something like this. My delegate del. So just defining a my delegate del, for example, right? And now what I see, I said del equal to del1 plus del2. Interesting. There was a delegate which was pointing to a function my method 1, and then there was a delegate 2 which was pointing to a function my method 2. And what I did, I just created another delegate, and I added together the del1 and del2, and now this del represents features of both of the methods, right? What does that mean? If I just call over here and I say del, for example, 10, now if I pass this 10 over here, right? So what's happening? Now I have got 2 functions over there. There are 2 functions over there. So now let's run that one. So you see here, right now the 2 functions, and let me just make a bit different over here. Like again, for example, it accepts a value and it returns x plus 5, right? Or prints x plus 5, not return. Now you see here, let's me run that. You see here, now by using one of the delegate, I am able to call 2 functions together. Does that make sense? Now what it does, it first of all goes and call del1. Del1 has my method 1, so my method 1 is called. So 10 is printed out as is. Now, since this del is now representing not only del1, rather del2 as well, the delegate 2 as well, and delegate 2 is calling my method 2. So now what it does is that, first of all, it calls this first method, and then it calls this second function, the second delegate. And of course, first delegate is just printing out the value without any change. And the second delegate is doing what? It is just adding one value and now adding to that one. Right? So this is one method of defining a delegate. And now this method will be called as what? Multicast delegate. This delegate, by the way, multicast delegate. Now, how it is multicast delegate? Of course, we know that this delegate is now calling two different methods and two different delegates, and both of them are basically calling the different methods together. Make sense? So this is basically what? This is basically one way of defining the delegate. So where one delegate pointing to the multiple methods, right? So now this also can be done by another way is, for example, if I just comment that out, and even I comment this one as well, rather I comment all of them. Now if you see that I have got a method one, which is representing, and the slide that I showed you, I'm just trying to make that sense for you. So as we have done over here, now see what we can do. What we can do is that I come over here and I say del1 plus equal to. Now what I'm doing, I am registering another function with my old delegate. I want to register another function with my del1. So I say del plus equal to my method 2. Does that make sense? Now this del1, which was pointing to method 1, there was only one method or one function, like it was pointed out by this del1. Now what I'm saying del plus equal to. Now, can anyone tell me? I have just maybe discussed this plus equal to operator is called what? This plus equal to. Does anyone remember the name of this operator? Plus equal to. Or if I ask you the full form of this statement, which I have written down, line number 12, if I ask you to give me a full form of this statement, del plus equal to my method 2 means what? It is a shorter version of something. So first of all, first question, what is this operator called? Let me just write down and then I'll ask them. Yes, thank you, Rashmi. Addition assignment. This is called addition assignment operator. Thank you, Rashmi. Thank you very much. Now, my next question. Can you just explain this? Okay, thank you very much. Yes, Akriti has given the answer, and yes, of course. Yeah. So Abhinav, it should be del1, right? And del1 plus my method 2. There is no del right now. There's no delegate over here. Yeah. So yes, you're right. So if I ask you that what is this statement, you'll say del1 equal to del1 plus my method 2. So what we have done, we have typically just mentioned it, that just keep on adding or registering a method to it. So we have registered a method to it. So if I call del1 and I call 12, whatever. So let's see what happens. So you see 12 and 17 because it's adding 5 to it, right? So 12 and 17. So I'm getting both of the methods being called over here. So that's basically okay, no problem enough. That was a typo. So this here, it is basically calling what? It's just calling both of the methods together. And now the same goes with as we register a method to the delegate, we can unregister as well. So what I say, del minus equal to, for example, my method 1. Right? Now, can anyone tell me, not Abhinav, not Rashmi, and not Akriti, because you people have replied. I don't want answer from you three, right? I want answer from someone else. I know you would know the answer. And if you know the answer, you can just write a yes or why. What will be the output now? What should be the output? What generic common sense says, what should be the output now? Again, other than these three people. Monarch says 12. Okay. Anyone else? Monarch says 12. Thank you, Monarch. Thank you very much for. So Abhinav, and if you people understand and know that, you can just write a yes or Y. Don't need to write the answer, but you can write a Y or something if you understand the concept. Okay, let's run that. Only Monarch has replied. Okay, Baldeep says 17. Baldeep, you may be right. Let's run this one and let's check. So answer is 17. Baldeep was right. Manpreet was right. So you know why? Just listen about it. So I had this my method 1 registered with this delegate 1. Then I added another method to it, my method 2. And then I subtracted my method 1. Please bear in mind, I am subtracting my method 1. So if I'm subtracting my method 1, it means now it won't call my method 1, which was just giving the value as it is. So if 12 would have come as it is over here, if this function, if this delegate was called, this function was called. Now what I've done is that unregistered method 1. So when you unregister method 1, it means that you are just taking this one out of the picture. So only method left with del1 is the my method 2. And my method 2 has this feature of just adding a 5 and then displaying the value. Does that make sense to those who were just saying about that one? Okay, right. So now it's basically what? It's just registering and unregistering. So this is an addition that we have done. And as I have done this addition, you know that it has become, of course, a multicast delegate. It has become a multicast delegate when you have just added something to it. Right. So this is the way of using that one. Now let's talk about another scenario. So there are different scenarios for that. A scenario might be something like this. Now I'm trying to create a delegate that should point to a method that has this this signature. So again, please bear in mind, usually we do not include signature as part of our we do not include return type as part of the signature. Do you people remember that? We do not include that as a part of the signature. But here, please bear in mind, when you are just creating a delegate necessarily will be looking for the return type as well. Do you see, as I have done that, we are getting this squiggly errors over here. So it says that it's a wrong return type or something like that. But anyhow, you know why? Because now this delegate is looking for a method that has this signature, again, including the return type. So you see, return type will also be counted over here. So now we have got it means that now this method does not serve our purpose. This method needs to have the same, the signature. So now if I want to make this signature same, what I'll do that in int, right? And not only int, of course, now I get a squiggly error over here. Why? Because it says you are not returning anything. So I'm just removing that one and I'm saying return x. So just returning the values in the same way as this function was doing before. So now one of the thing is now settled one, because now this delegate and this one has the same method, same syntax. But this one is remaining. Let me just go do that as well. Int, and now if you are inting it, it means you have to return x plus 5. Now my all program looks good, but still there is something that I need to do. Okay, so first of all, what I'm doing, I'm just deleting this one. Why? Because I don't want to unregister this one. I want to register. I want it to be registered over here. Now, what is remaining? Of course, now when I call this delegate function del1, which necessarily is mentioning or register, which has two methods registered with it. The first one is my method 1. The second one is my method 2. So both of these methods are registered with it. And it means that now I'm calling this del1. When I'm calling this del1, I'm calling both of the methods. And both of the methods return something. So it means I need to catch that value. You understand that? I need to catch that value. So return value equal to. Make sense? Because here we are not printing anything. So it means now I'll just try to print that as well. Console.writeLine and return value. Rather, let's make it a bit. The returned value is placeholder, not with commas, and this one. Right, so let's run this one and see if it works for us, or what it does basically. 17. Okay, Monarch says 29. Monarch, this is good. You have guessed it good, but again, it is returning 17. So what happens? Listen, actually what happens is when you call this function with 12 and it has two methods registered with it, it first of all calls this my method 1, right? So when first method is called, it returns as it is. So 12 will be returned as it is. So please bear in mind, Monarch, we are not, adding these values together. Rather, delegates behavior is that first it will call first method, but it will return 12. Then it will call the second method, my method 2, because there is the other method as well. So when it calls this one, it returns 17. Now what happens is, this is the default behavior of our delegates, that if there are multiple delegates, so the last method which is called, last method will only get the value from the last method. That is an interesting feature. But again, you need to keep that in mind, that if there are multiple methods, and another important point, that it goes on in sequence. It goes in. What does that mean? Let me just do that. I'm registering method 2 over here and adding method 1. Right? Registering method 2 and adding method 1. What should be the output now? Can anyone let me know? Rashmi says 12. Let's run that. Let's run that and check. Oh, the 12. And why 12? Rashmi, of course, you people can make sense of it, since this was the first method to be called, and the second method is now method 1. So if the first of all, first method will be called, this method 2, it will return 17. But of course, that goes somewhere in here, because we are not getting that value. And then the second method is called, and that second method just returns an X in its original form. So it comes up with a 12 rather. And why comes up with a 12? Because this method is called on the second part. I hope that makes sense to everyone. Exactly. Sequence of calling. Is it replaced by the other? Yes, exactly. You can say the value becomes replaced. So again, in essence, what I say is that when you call del1 12, first of all, here in this scenario, method 2 is called and 17 comes back. But of course, it's not the end of the world. There is another method in the sequence. So it goes to second method and call that one, and it returns 17. So now, or maybe this one 12. So now it just comes up with the 12 value. Yes, sequence of calling statement. This is important. That sequence is very important of calling of methods. So sequence always plays a very, very important role in it. Is that right? Does that make sense to everyone? Yes, means other function. Okay, so these are the two scenarios. Now there is one more scenario that we just want to cover it over here, and that is functions with out parameter. So there is a parameter out, if you people remember. Can anyone out of you just tell me what does this out represents? When we say okay, Monarch, you want to say something? You have raised your hand. Okay, in that case, what is the use of plus? Which case you are talking about?
Sir, as they are simply replacing the method 2 by method 1 into the delegate del1 object, right? So it is just an assignment, something like that. So where is the use of plus over here? If we write just del1 equal to my method 1, then also it will work as the same, that del1 is equal to my method 2 and del1 is equal to my method 1. So the sequence will be the same. I mean, method 2 will be replaced by method 1. and it will call del1. So where is the use of plus over here?
Excellent.
Because
Excellent.
I don't have a value of method 2 over here.
Yes, you are
In
right.
this,
So, Monarch, you have a very, very, very valid question. Now, listen about that, Monarch. Actually, you're right. One sense says that what is the use of this plus then, if we are calling that. But remember, multicast delegate has this feature that multicast delegates, you can always register multiple methods in it. So there are certain scenarios you might be needing, like again, you will say that this for example, I create this one delegate over here and I create another delegate. And I say, for example, del2, sorry, my delegate del2 equal to my method 1. Now see here. Now I have created another delegate with the name of del2. So what happens is that depending upon the situation where you are, when you are making your GUI, when you are making your different components, depending upon the situation, sometimes you will be just doing something like that the sequence will be playing a very important role. Now, it's not necessary that always you have a multicast delegate. So your question that what is the use of this plus? So in this scenario, might it look like that it's not doing anything good for us, this plus? Why? Because we are ultimately getting only one response. Ultimately, we are just getting this one response, and that is, as I said, that is the default behavior of that one. So to understand the concept, multicast will be used where in these situations where you are sure that, for example, that particular functionality might be needed in a certain situation. So it's not necessary. You are right. In this scenario, you might say that why in the world we are just using this del1. But you see here, when the value was assigned to this del1, it was method 2. But ultimately, we are getting method 1. Why? Because we are chaining these methods together. But this is not the real essence of chain. As Monarch said in the beginning, that answer should be 29. And he was right. Why? Because he was just mentioning. So if we were able to just chain those two methods together in terms of values, that would have been a separate benefit. But here what I say is that it's up to you, that if you feel that you have to chain them in a way, like for example, making them, adding them together, it works out for your situation, you will be doing that. But if it does not work out, you will not be doing that. So in essence, you want to say that this del1 is my method 2 and I will ultimately get that. So what is the use of this plus? The use of plus in this scenario is that this my method 2 will be overridden, or maybe the value returned by this method 2 will be overridden by this method 1. So depending upon situation, you might use or might do not use the chaining or this multicast the multicast delegates, right? So the last thing that we talking about this one is output parameter. So can anyone tell me what was output parameter? And okay, Abhinav, yes, go ahead.
I just have a little confusion in this delegate concept. Like, can't be used without using the plus equal to sign, and we can use the second delegate that is assigned to the method, my method 1, like that del1 equal to my method 1. That
Right.
will do the same task, but this assignment operator plus equal to is doing. And the same value would get overridden in that case as well.
Yeah. Okay. So what do you want to say? I understand what you're saying. You say that if I just take out this del1 plus, right, Abhinav?
Yeah.
Okay. And you say that still it's gonna do the same thing. You're right?
Yeah.
So Abhinav, listen. In this situation, what is happening? In this situation, we are we are doing what? We are just overriding or maybe just updating the value of del1.
Exactly.
Now, yes, you are right. In this situation, it looks like that both are acting in the same way. Why? Because my method was automatically, it was never called. Like, not for us, it was never called, right? But again, Abhinav, you might come across some of these situations when one of the method that you are calling might be doing something for the next method to be called. You know what I mean?
All right. Okay.
Yeah. So if that is the case, Abhinav, you need to have this chained together like this one. Like, chained means you need to have that added together. So as I said,
go
because
ahead. As of now, it seems overridden this one value to the another one, and only one of them is calling. That's why
Exactly.
the
So,
thought came in my mind.
but I hope you got the concept that what there is a whole lot difference between these two situations.
Yeah.
This situation, we are updating the variable. This del1 now becomes this my method one, and in this situation, one way or other, we are having that method, and internally in our stack calling, it should be providing some of the value. It should be providing something to that one. So if that is needed. Okay, so the last point, as I said, okay, welcome. Out parameter. So out parameter is used for what? For getting values returned from functions. You remember getting values returned from the function? And we can always get. So again, if I am defining this delegate in this way, it means again, it has to match the signature, and you see that signature is not matched. Of course, signature has started like unmatching. Now I'll come over here, and what I do is I'll do out over here. Now one of the method is get settled, method one get settled, but of course we need to do something like that. I have to do that one. Out int x. Now since it is just we are just setting the value, so I won't say voids like I won't return anything from this one. Rather what I do is that I'll say this is a void function now, right? It's a void function, and now it won't return something. Rather it can just do something. X is equal to any value that we are trying to set. You remember we have done that. So x is equal to maybe 15. I just want to set it to 15. So what it is doing, it is just setting up the value of this output parameter. X is equal to 10, x is equal to 15, whatever, right? So now what is happening is that now I have to just use that one. So now my delegate has this my method too. Let me just make it in a proper sequence again, just to we did that for understanding. Now we are doing that in the proper sequence so that we can just see the difference of the things. Now, so del1 is equal to my method 1 and del2 is equal to my method 2, and now del1 basically, sorry, del1 has these two methods together, and now we can just call this del1, and we can have a value. But again, of course, to have a value, we need to have another variable. For example, value out parameter, right? So value out parameter that will be returned, and we can just initialize it with -1 right now. Why? Because I want to have that value in my that. Why it is just giving wrong return type? Just wrong return type. Oh, sorry, this one. I have not changed that one. So since I'm calling that one, so I'm saying that this has to be white. Okay. Okay. Now this comment should be commented out. Now I have just defined one value out of parameter, and now what I do is that I'll call this del1, right, with this out keyword and this value out parameter. And now what I do is that I will just print value output parameter, or maybe just do that again. The value return or value of out parameter is right. So it is just calling that one. Console spelling is not correct. I'll just do that. Oh, console.log. I'm still inside my JavaScript. So please forgive me because I'm taking JavaScript course as well. So I'll just here and there making this mistake. And this console is not correct as well. Console dot, sorry, not that. Dot right line. I hope now I got it right. Right. So now let's run that one. So see here, same behavior that we have talked about before. Now here I have two methods like registered with my delegate. So first method is doing what? First method is setting up this out parameter to 10, and the second method is setting up this parameter to 15. So of course, what happens is that we have got this 15. So last method again doing the same thing, and this same magic can be returned by doing this one. And you know that now again these are changed together, but now what result I'll get? Of course I'll get 10, right? Because now the first function is setting up this value or returning this out parameter as 10. So in essence, what is happening is that always the last function which is called will be returning a value, and that will have that specific value together. And as I said, that we'll be just working on this one, and we'll just try to just come up with some of the examples and solutions, and then we'll just talk about that one in our coming session. So this is all about the delegate, multicast delegate. This was a question being asked by a student. As I said, we have just tried to discuss that. So we have just demoed all those different situations over here. And one thing that I wanted to just discuss with respect to our last class's code, did we discuss this lambda in last class? I think no. Did we discuss lambda in our last session? Like again, okay, Monarch says no. Okay, for that I will have to just open up my last week's code, because I want to just introduce this lambda over there, because there is a code that we have. Recent files, or I'll have to just open that one. Project solution, and that was week 6, right? Week6.cs. Let me just open that up. So you people remember this program? I hope you people have this program with you. And we talked about that. Now this is a program which is doing what? Which has promote by salary, promote by this one, and we have got this one was run by our like delegate, and when we use this delegate is promotable, this is promotable was passed over here, and it was just checking is eligible to promote or not. Now in that one, employee.promote employee list emp. So you see here, this is called lambda expression, and we can just replace this one with a lambda expression as well. So let me just do that. Yeah, this one over here. Okay, so now we can just do what? So when you are just calling this promote employee, and here we are just passing this promotable, and I just let me have a look at it, and I want to just use this lambda expression. Okay, so just let's right now let's take a quick break, and then I'll just discuss after the break. I'll have to just settle this few things into it. So let me just settle that one, and then I will just talk about this lambda expressions. These are very interesting, and let me tell you, those who have worked in JavaScript, they are very much familiar with this lambda expression. So is there anyone who has worked in JavaScript here, who has just worked in JavaScript before? Because I want to just discuss something related to over here. Anyone with JavaScript experience? So I just want to relate this one. If someone has a JavaScript background, or if they have seen, these are called arrow functions. This is lambda expressions over here are the replacement of those arrow functions that we talk about. Anyhow, I'll just talk about that. Let's take a quick break of 10 minutes. This is 8:46 in my clock, and I'll be back at 8:56, and then we'll just discuss about that. So let's take a quick break and be back. So again, not teaching JavaScript, but just letting you know that this function, all this function is converted into a single line or something like that. I can just write this complete function, or this one from starting from this point to this point, like this in a shorter way. So why again? So this represents that this a is passed as a parameter to this one, and the body of the function will receive that, and it will just work on that. Now come back to our business. But I say that emp has been passed. So emp will be passed, and it will be coming from this employee list, and that go and find out the feature of employee emp.experience and check if it is greater than 5. Do what? And again, so what you do is that you will be just passing this criteria again by using these lambda expressions. Here they are called lambda expressions. So this emp is representing the parameter that has been passed, and inside that we are checking, or maybe just returning. Here we are returning. So if you want to return something from here, for example, if I say this one is that, and this function is something like this, return a into a, for example, we are just returning something like that. So if it is returning something like that, so in lambda function, in arrow function, what we do, we will just represent this a into a, and that is all. You see how shorter this has become, the definition of this one. Same goes over here. And even if you see that we have talked about, we can just left out that one as well. So if you see over here that we have got, we say that this employee is a parameter that to pass to that, and check employee.experience, if it is greater than or equal to 5, do what, that criteria is being implemented over here. So this is basically lambda function. So it's basically new. So it might be a bit more clear in the coming slide. So here lambda and delegate. So what is the use of this lambda function in delegates? Prior to using lambdas, delegate could be used with the previously defined method. We have just done, and we know that how to use that delegate. We have just defined a delegate double my delegate, and it is just doing what, same ways which we have done before. Same thing. We had to use the name of the method to assign it to a delegate. So we use that name of the method. And what is the name of the method? If you talk about that, we have got that method has to be of the same nature. So we have this sqrt, and we just assign that method to it. This one, you remember, we have talked about that. And then this delegate represents this typical function. With lambdas, you can write an anonymous method which will be assigned. So anonymous method, if I show you these methods or these functions are called anonymous functions. So same way we say that we can write anonymous method which will be assigned to delegate. It is useful when the method is not used anywhere else. So you are not defining a method at all. You are just doing what? You are just passing a method over here. I'll show you an example, short example. Then hopefully this will be more clear to you in our Visual Studio Code. And rather, I will just now move to my current file. Why? Because I don't need to work on that one anymore. Okay, week 7 we are talking about. So you see here, we have got this code that we were talking about, right? So let me just make it a comment as well, so that you might do not get confused. I'll just make all these comment so that we have something cleaner. And now I'll just do what? Press enter and put that over here. Okay, so now I have got one delegate over here. Let me just define a delegate. So for example, I have a delegate public, delegate, the keyword delegate we'll always be using. And we have, I'm taking the same example that we have in that. So also delegate my del, and it will accept one double value. So it will return a double value and it will accept a double value, right? So this is so now what was the usual method of doing it? Usual method is that you'll define a method over here and then allocate it. But no, we are not doing that usual method. Rather, we want to do something interesting over here. And what I want to do, I say my delegate, right? Or maybe D equal to. Now you see here, what we do, my method, you remember I've got multiple methods. I could just assign them, even though there will be a syntax problem because that is a different syntax. But anyhow, I used to define method like this. Now I'm saying no, don't define a method. No need to define a method. Rather do what? Rather you do something like this. You say X as a parameter being passed to it, and you can call a math library if that is available to us, and we can just X. Now you see here, I am passing a function, a method which does not have even a name. Does that make sense to you people? There is a method we are so again what I had to do, if I write another statement of this one, same nature, my del D1 equal to, you remember I had to define it a method, or I have to allocate it a method. But this method is a typical name, my method one or something. So here what I'm saying, I'm not defining a method, I'm not passing a method or just assigning a method. I am just passing a lambda function, which is an anonymous function, lambda expression, which is an anonymous function. And this anonymous function will do what? It will just do its own job. For example, when X becomes a parameter, this X will be passed and it will return the square root of this X. Does that make sense to everyone? Now, for example, if I just call this one with console.writeLine, and again, I've moved to JavaScript, and we say D of 2, for example, or maybe let's take it 25, right? So I want this one to run. Let's run this one and see what will be the output. So you see, output is 5. Now, what is happening? I am not, so you see here, there is no function. Like these functions are all previous functions, and these are dead over here. I don't need them. So you see here, I am not defining a function separately. Rather, I am defining an anonymous function. Is that making sense to everyone? A bit, it's a bit, interesting to understand and a bit difficult to grasp, but I hope if you grasp it. So I am directly defining a function over here. Yes, that's a very good question. Akriti has asked a question, why we are writing X parameter twice? So why we are writing this X parameter twice? Can anyone let me know why we are writing this X and then X again? Abhinav has the same question. Listen about that. This X represents the parameter, and this X represents that value being used in that program. Oh yeah, you know the answer. That's good. That's good. Excellent. Thank you very much. So this X is a parameter of the function, and this X is used over here. Let me tell you something interesting. Take out this max.square root. X multiply X. Okay. So what will be the answer now? Can anyone tell me what will be the output now? 625. Yes, of course. Now you know why 625. Now I have defined a function. You see, Akriti, you are asking question. I hope you understand. This X represents the parameter of the function, and this represents the return. Should I take you back to my JavaScript environment? You see here, Akriti, can you understand this? For example, if I just take out this parameter, I don't know, this syntax is not allowing me to do that. It just adds it up. But again, in Lambda function, we can do that. So you see, let me just make it that so that you understand. Akriti, do you understand what is going on over here? For example, I can do something like this over here as well. If I have that available, for example, SQRT and A. Okay, that's good. Now you understand. So this is the parameter and this is the value. So if you see here, I am defining directly a function over here. Is that helpful, Abhinav? Do you find it helpful? Because now you don't need to create a function separately. What you are doing, that you are directly passing a function, an anonymous function, to my delegate. Does that make sense to everyone? I'm just asking, not only Abhinav, if everyone. Does that make sense to everyone? Now we are not defining the function separately. I am just allocating this function as anonymous function to my delegate. I'm hoping that everyone understands the concept. I'm not getting responses. Okay, that's good. Akriti, you people have been responding, but I need response from the others as well. What is going on over here? The method which had to be attached with my delegate has been defined over here. And this method or this function in this situation is called anonymous function. You understand why this is called anonymous function? I'll show it over here. That function does not have any name. We are not defining any name for that one. Just giving a parameter, and that parameter has been passed and it has been used over there. Right? So this is basically called as what? The anonymous function. It's an anonymous function that we have. Understand, everyone? So now if you have started making sense of these things, that this lambda function is very, very, very important, which produces an anonymous function for us. If I just show you again, this is our example that we have done. So it will be done what? This is a function being defined over here. Right? So what is what in lambda? Monarch, you have a question? Go ahead.
Yes, I have a question regarding, can you just please explain the second, the assignment part, or can you just go to the code, Visual Studio?
Visual Studio, you're talking about here? Yeah.
Yeah. So here X into X, can we consider it as a body of this anonymous function?
Exactly. Let me tell you something very interesting. Monarch, be unmuted. If I do something like that, which is wrong over here, but I'm just doing that. If I do something like that, does that make sense to you, Monarch? Now I'm just doing that. So making that right for, which is not correct for this situation. But do you understand the concept, what I'm saying? It's a my method.
Yeah, my method with X argument, X parameter, and the body is logic, which is X into X.
Exactly. You understand? And when in this way it is written over here, let me just make it back to the previous form. So Monarch, when it is written something like this, and there is there is a single value being written over here, if you see. So what does that mean? We are returning this value. You remember in JavaScript, I'll take you. If you are returning a single value, you will just mention that value over here, lambda function. You understand what I'm saying? That if there is a single value that you have to, okay, if there were multiple statements attached to this one, mind you, if there are multiple statements, like for example, this function has, for example, just for nothing, it has a console.log statement as well to print something, printing something, right? So if it had these two instructions, then to convert this function, I had to use that. In this situation, I had to use what? The body part. And why? Because now it has two values, and I will be just making those two values over here. You got my point? So this, yes, you are right. This represents the body of the function. Manak, you got the answer?
Okay, sir. I mean, in C#, in Visual Studio, if we have more than one line, then we can use these curly braces here as well. Right?
Exactly. If you want to create the body of this one, for example, you say that I have for example, I want to create a body of this one. But usually in C#, what we do is that we usually have, like, in situations where we are required to use those multiple statements, we might not be going for the anonymous function. We might not be going for the anonymous function in that way, right? Okay, so now this is basically the representation of that one. So if you come here, what is what in lambda? Any lambda expression can be written as XYZ, and this code in in these curly braces. The code can have multiple lines and return the result of the execution. If you have only one parameter, parenthesis can be omitted. So you see that you can just always leave out that parenthesis as well if you have only one statement. Now, here comes a very important feature of this one, lambdas and properties. You remember we talked about the properties of every class? Does anyone remember what were the properties? Yes, so Manar, can you just explain us, or maybe in the chat, or maybe if unmute yourself, what were the properties?
Properties were the getter set of methods, we can say that. We are dynamically assigning the value and returning the value.
Exactly. So the properties were set and get together. Yes, variables with get and set. And we had to just, we were just defining those properties. Now, a very interesting thing here, by using this lambda, we can make our properties more easier. Right? So let's do its example first. Again, this is a very interesting one, and I want you to just, have a concept of it. So I'll just, make it comment. I hope that you find this helpful in comment. That's why I leave all these things over here, so that you have got everything over there. So now we have got this class, and now I want to create another class. So I'll go outside of the class, and I want to create a class. So class testing lambda, right? I'm just calling it testing lambda. Rather, I should call the right name so that you understand. With properties, right? So testing lambda with properties. I've just named that, a very long name of this class. But anyhow, this will be helpful. So you remember that we had to define, we used to define the private variables. For example, here we say name, for example, and private int age. So these are the two private variables for which I want to define properties. You remember? And what properties I can define? I have to define a public property, and I'll say string, right? And what I can do is that I can represent one property which represents the name, right? And you remember we usually used to do what? Get and set. So here what we can do, I can say get, and I will say name. Set lambda function, right? And name equal to, what should I write? Can anyone remind me? Value. You remember the value comes over there and the property, right? So name equal to value. So set will be setting up the value, and get will be getting the value. Does that make sense to everyone? Now, same ways for the age. Public int. So I'm making this property. So I'll make it with a capital letter so that property becomes separate from that one. So now, if I want to get age, I'll do what? Get arrow symbol like lambda function, lambda expression equal to age. So whenever someone asks, just provide the age over there. And if you want to set the age, set age equal to, yes, what that? Again, value. Now, at that place where we discuss the properties, if you go over there, you'll find that now you can just use those properties and you can just mention those properties like this. Isn't that more, intuiting, or isn't that more interesting to use these properties like that by using lambda expression? So lambda expression is also helping us out in making these type of things. So you see here the same example I've just, with different words I've used. So you can just use this set and get over here by using this lambda properties, right? So that is the lambda expression. Do you find this lambda is interesting? It's a very interesting thing, lambda expression is a very, very interesting thing. And here it is saving us a whole lot of world over here. Why? Because we are just having this one, and we are just, defining that one. And I think this lambda expression it's a very important thing, and you need to understand that. And again, I've given you a quick sense of that as well, that in JavaScript as well we use that one. But in JavaScript, in the modern JavaScript, they are called arrow functions. These are called arrow functions, not something else. In JavaScript, they are called the arrow functions, right? So I've just defined a class and testing lambda with properties. So now we have got this get and set and all these properties being set by using what? By using our, lambda expression. So lambda expression will make our life easier, right? So now let's make it comment. So that is what in lambda. So lambdas and properties, we can just always use them in the properties as well, and we have got all those working over here. Now we have to jump back to OOPS, like object-oriented programming, and we have to discuss specifically some inheritance related issues. So let's start talking about OOPS again. So we have just switching the gears. Right now we were in on some different topics that we had, and now what we are doing is that we are just defining that particularly, and we are moving back to our object-oriented code. So now let's start. So we encountered previously that we know that there are certain things that to be considered. In the previous lectures, we spoke about polymorphic relationships. There are different polymorphic relationships. We encountered two very interesting situations. Base class does not have to implement any methods because all of them will be overridden. So base class, generally, if you say that whenever you create a child class, right, again from a parent class, you say that you override all those methods. You remember we have talked about virtual, we have talked about override. So when you have a base class and base class methods are overridden by the most of the child classes, so they say that one of the situation, an interesting situation, is that base class does not have to implement any methods because all of the method will be overridden. So they say that why we are just defining base class method if they are to be overridden by the child methods, by the driving class methods. This is one of the situation. Now base class can implement some of the methods which will be used by drive class, but other methods do not have to be implemented. So these are the situations that we want to handle over here. First situation, base class does not have to implement any methods because all of them will be overridden. So if there is a situation where you feel that all of the methods will be overridden by the drive class, so why we are defining them in the class? So those who are familiar, we are talking about here in interfaces and abstract classes. So that will be, as I said, that will be our last topic with respect to this command line environment, and then we'll move to the WPF or our Windows environment. Anyhow, so we are talking about these two methods. The problems we face: if a method has to be implemented by all drive classes, can this be enforced? Now the problem is that we want one method to be implemented by all drive classes. Can we enforce this? What does that mean? There is a method in a class. We want all child classes to definitely give their own implementation of the method. In that scenario, here is a question: can we do that? Can we enforce classes to definitely define a method? Typically for a typical situation, can we enforce that? Can this be enforced? Question number one. You know what I mean? This is our class and this is class A. right? It has a method ABC, function ABC. Now, what I want that whenever a class derives from this one, for example, a new class is created like B, which is child of this one. I want every class to definitely implement ABC method of, like, their own definition of ABC always should be there. Can I do this enforcement by using our classes? Does that make sense to everyone? So this is the question. This is the problem that we have. If some of the methods do not have to be implemented in the derived class, can we relax this enforcement? Or maybe I say that there is another method XYZ, and I don't want all classes to implement. I don't want to enforce everyone to implement that. Make sense? I don't want. Here I'm saying that I want to enforce ABC should be implemented in every class. Then I am saying that there is one another method. Can I do something like that? I say no. Okay, if you are not implementing XYZ, no problem. You can use the definition of XYZ from the parent one, from the base one. Can I do this relax? Can we relax this enforcement? Can we do something like that? Do the methods implemented in base and derived classes have to be virtual? So these are three questions, potential questions that have come out of these situations. So again, can we enforce a method to be implemented? So for the first one, you are saying, Abhinav, yes and no? Okay, so yeah. So, and for the second one, can we relax this enforcement? We don't want classes to implement.
We can do so by using the concept of inheritance.
Exactly. And do the methods implemented in base and derived class have to be virtual?
Yeah, like if we have the same method in both of these type of classes, base and derived, and the subsequent classes are inherited or acquired some method from these classes. So obviously we have to make use of virtual override over there.
Yeah, that's right. So now we'll just talk about these questions, and we'll just try to address these questions. We are about to address these questions. The first thing is interfaces. Interfaces in C# give us the ability to solve the first problem. What was the first problem? How to enforce, right? How to force classes to implement a required method or methods. The interface declares the method but does not provide any implementation for them. The interface does just what we need, forces the class which implements it to implement all methods of the interface. No fields in interface. Interface does not have any field. Anyhow, listen about that. If we create interface in our program, interface has this ability to force classes to implement methods. What does that mean? I'll just give you first example and then we'll talk about that one. Okay, so let me just make it this code at the bottom so that this is also available, but we'll talk about. Okay. Right. So let me just define an interface over here. So to define interface, same, the keyword interface is used. Right. We can just define that one. And it's a general tradition that we always start interface name with capital I, right? To represent that this one is an interface. For example, if I employee or whatever, we can just define an I employee interface. So I'm defining an interface. So the first property, if you come back over here, the interface declares the method but does not provide any implementation for them. What does that mean? So in this interface, for example, if I say void and I'm defining a print method, I will just keep on using this print method, and I'm giving its body console.writeLine hello from interface. Now what I've done, I've given this definition. Now in this, if you go and just build this solution. Oh, it's building successfully. That's interesting. Not giving there. Okay, I'll have to check that why it's just giving that. Anyhow, the first thing that we need to remember. Okay, just hold on a minute. Let's create its variable, for example. I employee, and we cannot do that. Those who know about that, equal to new I employee. So you see here, first of all, like first property, there are different properties. I don't know why it is just doing over there, but anyhow, if you see that we cannot create the object of interface, as we cannot create the instance of an interface. So first of all, second thing to remember is, I don't know why it is giving over here, that you never define a definition. You never give a definition of a function. You are not allowed to give the definition of a function. Rather, you are always just defining the functions over here. We just define a function over here with the name. Personal thinking while defining a method. Yeah, exactly. You're right. That's what I'm thinking. Abhinav, can you try it in your own in your environment as well? Is it doing the same? I don't know why it's giving. It should give an error. It should throw an error. Abhinav, can you check in your your IDE? Yeah, try it quickly. But again, in the meantime, I'm discussing that a function should not be. This is what I have done. It is not allowed. Please bear in mind, we are never allowed, never define a function, never define a function completely, like define the body of the function, so to speak, body of the function. So we never define the body of the function in an interface. Interface is just there to represent the name of the functions. So who defines that? Who defines that? So whatever, like for example, if there is a class, for example, I have this one class. I'll just create another class over here. Class employee. Now I'm creating a class employee. And colon, you remember why we use colon? For inheriting. And I am inheriting this employee. So I'm creating a class and inheriting an employee. I employee. Right? So I'm creating a class employee that is inheriting from I employee. You see this squiggly problem? Of course, it says that employee does not implement interface member employee dot print. I am right now forced to implement this method, which is print method. Why? Because there is no definition of print method over there. So now one of the easy way of doing that is, again, it will give a typical definition of that one. If I say implement interface, I'll do that. I'll say implement interface. You see what has happened? A print function is automatically declared over here. Do you understand? And why it is declared? So just don't worry about this throw not implemented exception. It's basically there. This function is coming up. Why? Because this class is inheriting from this interface. And when a class is inheriting from an interface, it has to have the function definitions, all those function definitions which are given over here. So if I do something like this, print 2 and leave that one and save that, you see again squiggly error has appeared. It says that there is something that you have not implemented. So go and implement that. So I'll say, okay, implement that interface as well. So it has added the print2 function as well. Now, let's talk about why this is throw new on implement. Why? Because we have not defined the body of this print. So of course, this is giving this error. So right now, I'm just removing this second function. I'm not doing this second function right now. We'll just play with the one function. Do you understand that an interface just gives the declaration of the function, not definition of the function? Body is not there. Body is always defined in whatever is just inheriting from that one. So they are created just like classes. They can create, they can contain methods, they can contain delegates or events, but they have no implementations. They should not have any implementations over there. Right? So if you come here, you see the interface declares the method but does not provide any implementation for them. So it just declares the method. It is just declaring a method void print. And who has to define that? Who has to make the body of that one? That class which is inheriting from this one. Right? So this exception is thrown. Why? When if you say that, of course, this one, I am not defining this print function, so it will say, okay, so if I come over here and I just create an employee object, so I can create the employee object. I can never create, you remember, I can never create the, so you remember I employee. If I want to create an I employee object, obj I employee equal to new I employee. So can I do that? No, this is not allowed. interfaces cannot be instantiated. Interfaces cannot be instantiated. So who instantiate in interface? The class which is inheriting from that one. Abhinav, have you checked? Is it throwing an error for you? I'm waiting for your response. Anyhow, so now if I run this program, and of course employee has this print method, I'll just call that print method obj.print. So what will happen? What people say? Actually, my VS is loading up, please. Okay, no problem, no problem. That's not a problem. Now you see here. Now obj.print. So this is the question. What should we print it out? Should it print something or should it do something wrong? Anyone else than Abhinav? Abhinav, I don't need answer from you. What should we do? So let's run that one. So you see that what is happening? Not implemented exception has occurred. Why? Because you know that we have thrown this exception by ourselves. You remember we used to throw this exception. So now what I do, I come over here and I implement this function. I say console.writeLine and I say I am print function inside interface. Right, so I'm a print function inside interface. Now it should run. Of course it will run now. Now there is no throwing of error right now. We are not throwing an error, explicit error exception. So that's why it should successfully now run. I am print function inside interface. Does that make sense? Now what I've done, I've just given the definition of this print over here. And this print function is basically now working on that. And this function is now called. And this function is coming from where? Like again, it has been declared in my interface. And now it has been defined in my class, which is basically doing what? Which is just inheriting from that interface. So again, the concept that you need to remember. A class or a structure can inherit from interfaces. Because of new update with C#, you can now have default implementation methods in interface. Okay, yes, that's right. So this I was just also considering this is a new update. So thank you very much. Someone has privately just mentioned that now this is not an error and this is an update that you can have a default implementation. Thank you very much for pointing that out. There's a student who has just pointed that out and says that. Have you Googled it or you knew it before? I'm asking to those who have sent me a direct message. Okay, right. Yes, so I had this understanding that the latest update might have some different implementations, but again, in the classical sense or in the real sense, the interfaces should not have definition. So someone has, thank you very much for them for sharing that one. So someone has shared that now we can just define an implementation. So it means that now what we have is that I can do something like that, which is default method, right? So it's again the latest addition to that one, and of course we can just work on it. So again, if I just do not define anything over here, for example, I don't know it should work or not, because this is something, no, not log, right line. I'm again in JavaScript. So I've just created the class and it says that obj print cannot be called. Why? It says employee does not contain a definition of print and no accessible extension method. So again, there must be a method for defining that one. But anyhow, just for the time being, plus be with me, and I'll just come up with this description as well. Yeah, exactly, same update. That is happening because of that same update. You're right. So now what I'll do is that again, if you want to implement that, so you just typically go over there and just do that one. And implement interface, and we'll have this method, and I don't want this one, rather I want to this console.writeLine over here, and I say I am inside class coming from, like, it's coming from interface. So I'll talk about that one as well, the other situation. But anyhow, just remember that this is basically a situation where that. So a class can inherit from multiple interfaces as well. It's an interesting concept. You remember, can I inherit one class from multiple classes? Multiple inheritance is allowed or not over here? Multiple inheritance. You remember that multiple inheritance, yes, multiple inheritance is not allowed in our C#. Not allowed. Multiple inheritance not allowed. But multiple interfaces can be inherited over here. Just to give you a quick sense of it. So I define another interface, rather copy this one. I employ 2. I'm just saying I employ 2. Right? And to just to remove the ambiguity, I'll come to that one as well. There is an ambiguity and there is issues related with that. But anyhow, so I'm just defining another employee 2, and the method is also called print2. And now we have got, so now I can just extend it from different one. So I can say I employ 2 as well. But of course, I'll get this quickly error. Why? Because I'm not implementing the method print2. So if I go over there and I say, okay, just go and implement the interface, it will define print2 as well. And again, this is print2. So I want to just, replace it with console. I don't want to throw an error. Rather, I want to just print, I am inside class coming from second interface, right? I'm coming from second interface. So it is something that is coming from the second interface, right? So now what is happening, that it means that a class can inherit, excuse me, class can inherit from two different interfaces together. And now I have this liberty of the first function print1, and then I have the liberty of print2 as well. Why? Because now I am inheriting from 2-1. So please remember, multiple inheritance from multiple classes is not allowed, but multiple interfaces can be implemented, can be used, right? I'm just writing that so that you have the comment as well. Multiple interfaces can be allowed. And now you see that both of the methods are available to you. Understand, everyone? So class can inherit from more than one interfaces. The issue is that like that, right? So a class can inherit from multiple interfaces. So here they have just defining. So we usually define interface in the separate file. The interface has method stubs which declare method signature for all implementation of interface. Because of this, the feature interface is often called as contract. It is called a contract between a class, this employee, and between these interfaces. This is called a contract. And what does it mean, contract? If you are implementing me, if you are extending me, if you are creating yourself on the basis of myself, what you need to do is that you need to define these methods. If you are implementing me, I employ, you need to have print method. If you are implementing this I employ 2, you need to have this print2 method. Is that right? So we know that class cannot inherit from multiple classes. Multiple inheritance from classes is not allowed, while as multiple interfaces is allowed. For example, if you are using multiple interfaces, it is allowed over there, right? Oh my God. Oh. What are you doing? Okay, just. So it can be multiple interfaces allowed, right? So interfaces are like that. So it's one thing that you have to just remember, that interface have method declarations, and those method declarations, what we can do is that we can just use those method declarations by using this one. So again, that is a concept that you need to keep with yourself. And now let's discuss another interesting thing. When we have this, this is called if both of the classes have same function. Now we have seen this type of problem today in the morning as well. So if it is print2, I don't need this one. Now from either first or second interface. Now listen about that. We have got two interfaces and they've got exactly the same method. So when I'm implementing this one, you see that I have got only one definition. So now it is starting to become ambiguous that which print method it will be using. For example, when I'm calling this print, of course print2 is not there. If I'm calling this obj print2, so let's see. First of all, it's not ambiguous right now because there is only one function we're defining. I'm inside class coming from interface from either first or second interface. I don't know where I'm coming from because both of the definition, because this one definition is basically enough for both of these declarations. So which one it is calling, that is something we need to just, we need to identify, or we need to know that which one it is calling, right? So it's a problem now. Problem means two interfaces having same name, same method, and what we are doing is that we are defining this once time. It is basically becoming enough for both of them, because it says that, okay, for iEmployee, print method is there, okay, this method is there, but we don't know which method has been implemented or which method has been called over here. So again, in this particular situation, this does not matter that what is that, because there is only one print function, right? The situation will become interesting when we have explicit interface. Let's first of all talk about this situation. Now, if I want to access it with a typical particular class, if I have this facility of accessing that one with a typical class, and what I can do, let me just tell you what I can do over here. I can do something like that. So I say, rather than calling this obj.print, I'll cast my object. What does that mean? I'll say in iEmployee, and then I'll say obj, and then I'll say dot print. Even though, and as I said, we might not look at the difference right now, because we have got the same only method. So you see what I've done, iEmployee obj.print. Do you understand? Now I'm explicitly talking about this iEmployee first interface, not the second one. Does that make sense? Right now it's not making too much sense with this only one function over here, but anyhow, if you want to just access a particular class method, what you'll do, iEmployee2, and you say obj.print. Now I am exactly sure, yes, I missed out this one. Now I'm exactly sure that now what is happening, that this first one is calling the function or the method from first interface, right? And the second one is calling the function from second interface. You see here? So basically, this is one way of doing that. You cast your object, cast your function calling. So what I did, iEmployee obj. So I have casted this one into iEmployee. Which one? The first one, right? And then calling this print function. And here I'm just casting it with the second one, right? So that's basically that's one way of doing that. Now, situation, or what else we can do? There is a very interesting thing that we can do. In this class, I can explicitly define functions for that particular things. Now, to define explicit function, the first thing that we need to do is that we need to take out this public keyword. I'm defining explicit function. Now what I'll say iEmployee dot print. Now, if it is iEmployee, I'm talking about first interface, right? I'm just removing that one. This is called explicit definition of a function or of an interface method, right? Now come here. I want to define the other one as well. Void iEmployee2 dot print. Right? I'm defining this one. And now this is from the second one. Second interface. Right? So now if I ask you that, now we have got now. So see here, we can feel the difference over here. Now can anyone tell me what will be the output of line 40 and what will be the output of line 41? Do you see a difference over here? Now let's run that one. Run and see what comes as output. Do you see that both methods have been called over here? First, not either. First interface, second interface. The first method is called, of course, we are just calling it over here by defining it. But what we have done is that we have just defined this one as a like, the explicit. So this is called explicit interfacing, explicit interface methods. Explicit interface methods. What has happened? Okay. explicit interface method. We are defining explicitly for which class I am defining that. So employee.print, employee.print, I employee2.print. So I'm saying that this one is the implementation of this one, and the second one is the implementation of this second one. Make sense, everyone? Now there is another way of, interestingly, there is another way of doing that one, and this will be the last thing that I'll be discussing in this session. Making it comment for the time being. Now, if you see here, I can do something like this. I employee, and I said to you that we cannot create object of employee, object of interface, obj interface. I'm just calling it obj interface, right? So obj interface equal to, and you remember we can never create this object. Why? Because interfaces cannot be instantiated. So if I do something like this, new I employee, again, this one is an error. Of course, it will say that I cannot initiate that one. But you have seen that in exam as well. You know about that. I can do something like this as well. This, at least. This is interesting part of it. Do you people understand what is going on? Let me just create another one. Interface 2. Now, if I call, of course, from obj interface, simple interface dot print, and if I call obj interface 2 dot print, do you understand that both of them are calling the different functions? This one for this own print method, and this one is for the on print. But I hope you people understand what I'm doing over there. So you see one first and the same method, same output. But do you understand what is going on over here? I cannot instantiate the interface variable, but what I can do is that I can create this, the object reference of this I interface can be assigned to its class. You remember the base class and child class concept that we talked about when we were talking about the inheritance? We have talked about that one, that you can just define a reference object of child class, and you can allocate the reference variable of parent, and you can allocate it the child's object. So if you see here, this employee is just like a child which is inheriting from these two one. So what I can do is that I can create the object of I employee, and I can allocate it new employee. I can so this is another method of calling this one. Now, very interesting aspect which I forgot to discuss. Let me just discuss that one as well. When we had this situation, you see, I'm talking about the previous situation now, right? So you see here that we have got something like this. Now, interestingly, if I take out these two statements, or again, if I make them comment, and I want to see that if that print method is available to obj or not. So obj dot, you see that print method is not available. Can anyone tell me why this print method is not available over here? Why print method is not? Situation is this, something like this. So it says that I do not have, obj does not have a print method that was associated with it, which was there before. But why it is not over here? Child class cannot. So why you are sending me direct messages, Rashmi? I don't know. You can send this. This is a very general. So now you see that why print method is not available, because this print method is now associated explicitly to some interfaces, and print method has no general understanding of this one. So print method will not be accessible this way. Rather, print method will always be accessible by using this way. It will be accessed by this. Oh, sorry. It will be accessed by using this way. You see, so now I can call this print method. Is that right? So now this is the situation for the interfaces. So I will just, today I'll just stop here. And what I want from you people is that I will just share right now this code with you, and I'll update this code for the next class. And I want you people to just have a good understanding of two things, like again, the lambda function, which is very interesting, and as well as this one. So I'll share this PowerPoint slide as well with you people. So I'll be just stopping here. I'll just keeping to this point. So now we have this now implementing interfaces. So there are lots of examples, but again, I'll be discussing for all those all those features as well in our coming classes. But today I'm just keeping to this point. I'll share these slides as well, and as well as I'll share this code with you people. Yeah, so some people have questions related to assignment 2, I think. So what I'll do is right now, so I'll just try to take those answers, that questions from you people, whatever you have, or maybe let's do it some way that who has the question related to assignment 2. Someone was asking about the assignment 2 in the beginning. Who was that?
Professor me.
Yeah. So what do you want?
So